Okay, we're going to start chapter 2 today, and chapter 2 is on descriptive statistics. So if you remember from last chapter, descriptive statistics is the branch of statistics that involves the organization, summarization, and display of data. So that's what we're going to do here. We're going to take our data, and we're going to organize it, summarize it, and display it somehow. Okay, so to start, we're going to do frequency distributions, and there are different graphs. There's a lot of different words and whatnot we're going to learn here, including things like frequency distribution and limits and midpoints, relative frequencies, cumulative frequencies, and boundaries, and how to make graphs using these different things and to make different graphs. So to start, what is a frequency distribution? So basically, as it says here, is a grouping of data into mutually exclusive, means no non-overlapping categories, showing the number of observations in each. So for instance, in this particular table, we have 7 classes. The first class is from 11 to 15. The class width tells you how far apart the classes are, or how many data points are within the class. It's the same thing. So you can find the class width by taking 2 lower class limits and subtracting them, consecutive lower class limits like we did here, 16 minus 11. The other way to do it is you can take the particular class, the upper limit, so I'm looking at the first one, minus the lower limit, and you always have to add one, because when you subtract, you're taking away that last number. So when we're talking about numbers inside a class, you need to do that. Add 1 at the end. So you still get 5. If you count on your fingers, you do 11, 12, 13, 14, 15. There are 5 numbers from 11 to 15. But when you subtract, you're technically getting rid of that last number, that 11, so you have to add it back in. Okay? So you have a lower class limit. So in this case, that circle there, that's 36, and the upper class limit of that class is 40. So the left side is the lower, the right side is the upper. So you mark that. You can do tally marks to see how many are in each. It's sometimes helpful if you have a big list. And then the frequency is how many tally marks you marked, or how many of the data points are in that particular class. It's important to make sure that your total frequency here, when you add it up, equals how many data points you have. That's a good way to make sure you caught all of them from your list. So, how do we know how many classes to make? Well, if you're not told, and a lot of times this year in this book or on assignments or whatever, they're just going to tell you, hey, make 5 classes or make 6 or 7 or whatever. But general rule of thumb is the 2 to the k rule. So, for instance, if you have 30 data points, you want to think of what exponent, what power of 2 will get you past 30. So if you think of 2 squared is 4, 2 to the 3rd is 8, 2 to the 4th is 16, 2 to the 5th equals 32. So k equals 5. That would make a good histogram display. It doesn't have to be, like the previous example, they made 7, but that's a general rule of thumb. And then figure out how wide each class would be. You take your high minus your low and divide it by how many, that k value, how many classes you have. So let's look at that in an actual example. So the high in this list, if you look through it, is 504, or I'm sorry, 405. And the low is 155. They tell me in this case to use 6 classes. So I'm going to divide by 6. I get approximately 41.6 repeating. So you're not going to use that, obviously. You're just going to round it up to 42. So you don't want to have a decimal there. You want a nice whole number. Okay? So here's our classes. So 155 197, 239, 281, 323, 365. Those are all exactly 42 units apart. And then you can tell the upper class is going to be, you know, the one below each of those. So 155 to 196, and so on and so on and so on. All right. So because we have the smartboard up here, I'm just going to use my highlighter and mark the numbers off as I go. So 155 to 196. I want to look for anything less than or equal to 196. So I'm just going down the columns. There's 1, 2, 3, 4. There's 4. Now the next number in my list, the next upper class is 238. So I'm looking for anything less than or equal to 238. So that's 1, 2, 3. That's it. There's just 2 of them. You kind of go down through this. And if you do it in this way, you can just highlight and mark off less than 280. Seven of them. 322. 9. You can do tally marks and have another column there, but 364. And then you have 3 left. And if you add those up, you get 30. So we haven't missed any. Okay? So however you want to do that, tally marks, go through each list. Okay, so we've double checked that our frequency adds up to our total. So the other things we need to be able to figure out are the midpoints. So that is basically taking the lower and the upper limits of the class, adding them together, and dividing it by 2. So that's the midpoint, or sometimes called the class mark. So if we go back here, bring this back up, 155 plus 196. Divided by 2 is 175.5. So that would be the class mark for that first class. The relative frequency is basically what portion or what part of the group total is in a particular class. So if you had 4 in that class out of 30, that would be your relative frequency. They can be seen as a fraction, a decimal, or a percent. Cumulative frequency is just the running total. So in the first class we have 4, in the second class we have 2. So the cumulative frequency for the second class would be 6. So you had 4 and then you added 2. And so on. All right, so the next slide we're going to continue that table and find midpoints, the relative frequency and the cumulative frequency. So as we said, 155 plus 196 divided by 2 is 175.5. And then you can do the same for each class, or since we know the class size is 42, I can just add 42 to each midpoint to find my next midpoint, or class mark, as they're sometimes called. So we're just adding 42. Okay, so there's all our midpoints. The relative frequency, again, we are going to divide the frequency by the total, and we said the total was 30. So 4 divided by 30, I'm just going to go ahead and put this as a decimal. And then you just go through and you do all your dividing. Rounding to the nearest hundredth in this case. So there's our relative frequencies. So for instance, there are 13% of the data points are in the first class. 10% of the data points are in the last class between 365 and 406. So you can think of those as decimals, percents, or fractions. So cumulative frequency, in the first class I had 4. In the second class I have 2, so 4 plus 2 is 6. And the third class we have 7, so we add 7, we get 13. So it's a running total is what this cumulative frequency is. So our total should equal our cumulative frequency total. So we can make different frequency distributions. The first one we're going to talk about is the frequency histogram. It's basically a bar graph that has a horizontal scale that is the quantitative measure of the data, and the vertical scale is the frequency. So in a histogram, the bars have to touch. So in a bar graph, they don't. So I want to look at this real quick, point something out to you. So if you're looking at the bars and how they have them labeled, we have 100, 150, 200, 250, 300, 350. The problem with this particular graph, there's a slight problem, you do not know, for instance, where 200 would go. Would 200 go in this bin, this class, or this class? Where does the 200 go? So when you have something like this, it's kind of good to put a little key. So for instance, in this class here, the 150 is not included, but the 200 is. So 200 would be in this bar, 150 would be in this bar. So it kind of tells you that the number on the right side of the interval belongs in that bin. So just a little side note. We are going to do the histograms a little different, and we're going to use that midpoint first. Okay, so there's my frequency table by midpoint, and we are setting up our horizontal axis is the expense for the prescription drugs in dollars, and the vertical axis is number of adults that spend within that range. Okay, so we have 4 for the first class, so we're just going to do a bar up to the 4, easy enough. In the second class, with a midpoint of 217.5, we have 2, so we do a bar to the 2, and the next one is to the 7, and then to the 9, 5, and the last one is 3. And sometimes you will see above, they may write the totals. Sometimes they write them in the bars. Sometimes they just leave them blanking. You can just figure those out yourself when you just go across to the vertical axis. Okay, so that is a histogram labeled by midpoints for the out-of-pocket prescription medicine expenses. Okay, so class boundaries is another way to write the line or the numbers on a histogram. So a boundary basically, since the upper here and the lower here are just separated by 1, we're going to split that difference in half and go by halves. So the class boundary, you're going to subtract. So we were at 18 for this first class. We're going to take a half away and sit at 17.5, and then we're going to add a half to the 25. So the class boundaries are going to match here. All right. So when you're looking at a class boundary, you know that you would add a half and subtract a half. That's your true limits. So boundaries are different than limits. Boundaries are the numbers that are kind of touching, but you can see there's a split there. That's the in-between number. Okay? So if we're looking, this one on the left is midpoints, and on the right is by class boundaries. The graphs themselves, the heights and everything should be exactly the same. So the orange and the purple part, exactly the same. On the left side, we have midpoints for the horizontal axis. On the right side, we have boundaries. So if I'm looking here, 155.5, 196.5. So I'm going to add, if I wanted to know the actual class limits, I would add a half to the left, and I would subtract a half from the right. So that's the class limits of that first class. the lower limit and the upper limit. This one on the right is also a relative frequency histogram. So notice the vertical axis is no longer by frequency, it's by relative frequency. So you can see here, about 7% fall in this second bin. Okay, so it's by relative frequency. So frequency polygon is another graph you can do. So again, this is the one that's labeled with class midpoints. And we need to put 2 more points on our horizontal axis. We want to subtract 42 and add 42. We want to add 1 class above and 1 class below the midpoints there. So when I'm doing the polygon, I would always start on that lower, not really included, extra midpoint. And then you just go to the top of the bar and the midpoint, next bar, and you're graphing these points. These are vertices of your polygon. And you want to again add 1 class width at the end. So you should start on the horizontal axis, go up to all your heights, and then go down to your horizontal axis at the end. And then you are going to connect these guys with a line. So we're going to connect. This is what's making our polygon. So do we have to have the bars to draw this? No, you don't. Okay, and actually you don't want to have the bars there. You want to take those all away. You want to leave just a polygon. Okay, so that is a frequency polygon. All right. An ogive, or ogive, is a graph that shows cumulative distribution. So it could be cumulative frequencies, cumulative relative frequencies, or cumulative percent frequencies on the vertical axis. Okay, so this one's just a cumulative frequency. And again, it starts, the left endpoint is 10, the right is 15. And again, this one doesn't show the boundaries, so it's kind of one of those, you're not sure what's what. But this, if you kind of picture the bars here, that's what the bar would look like. And then the next bar. Okay, so we're only doing the dot at the top of the right upper class width there. All right, so again, this is the bar, and then this one's a little bit higher. So you can kind of picture the cumulative frequency bar graph here. And we're going to the right side endpoint. So at the very end, after the 35 days, you should be at the top, which is 20. Okay? So if we're looking at this guy, and we wanted to do one of these for our data, I already have the dots here. So we're going to start on the left boundary on the x-axis. And the right boundary, we're going to go to 5. Here, this is the right side of that first class. And then the next one's going to be at the 8. And again, you're kind of estimating because we're going by 3s on the vertical, and then we're going 14. And I've got little green lines to kind of help me guide mine. I wouldn't be able to go up straight. We got it. A nice ruler would be helpful if you're doing a project. And the last one's at 30. Okay. So you don't have to have the bars there. You can just do what we did there. And you're going to connect them. error for some reason. All right. Now, here you can kind of see some information. Like, where is the greatest frequency? Well, it doesn't really tell you the total number, but if you look, you can see the steepness. This piece right here is very, very steep, which means it went up more than the other. So between 293 and 338 in that interval here, you had greater frequency. Okay. And you can see that's the 9. All right. So let's try and answer some questions here. What type of display is this? Well, that looks like a frequency histogram, and it looks like it's boundaries, because it's supposed to be in whole minutes, so these are boundaries. What's the total frequency? So if I added up the 6 plus 10 plus 13 plus 8, etc., you should get 50. How many classes are there? Well, how many bins do we have? 1, 2, 3, 4, 5, 6, 7. We don't want that. Ignore that. How many classes are there? We're just going to write 7. The class width, if you just subtract, you get 12. You subtract boundaries. What is the lower and upper class limit that has the greatest frequency? So we're looking at this bar in the middle here. And again, 13.5 or 30.5 and 42.5, you are going to add a half to the lower and subtract a half from the upper. So it'd be 31 to 42. Okay. All right. This is a polygon, frequency polygon. I have that written there. How many classes are there? So you can't count the dots because you have an extra one on the left. So count in between. So 1, 2, 3, 4, 5, 6. What's the class width? So again, we're subtracting. These are again by boundaries. What's the greatest frequency? 40. What's the least frequency? That would be 5. Describe any patterns. Well, these are test scores, and if you add up, there's different patterns you can describe, obviously. There's 100 kids that took this test. If I added up all the frequencies, then it looks like 40 out of the 100 scored between 80 and 90 out of 105 points. Okay? So you can just describe whatever you see there. All right. Last one. What type of display is this? Notice it keeps going up, up, up. It doesn't come back down, so don't get it confused with the polygon. This is the ogive. How many are in the sample? 30. That's the top number. What is the class width? And again, we're subtracting. You get 5. What is the greatest increase in frequency? Well, let's look at the steep. I'm going to say this is about at 9. This appears to be about at 17. So that's a difference of 8. This is about 25. That's also just a difference of 8. So they're going to be 8. What is the lower and upper class limit of the class that has the least frequency? So again, these are boundaries. So we're going to add a half and subtract a half. So it's going to be 9 to 5. Or 5 to 9. So hopefully you understand a little bit more about histograms and frequencies and relative frequencies and all different sides, parts, and types of graphs.